notes packet, and you might want your postulate sheets. Today, you're going to see a shift in what we're doing in Chapter 5. The beginning part of Chapter 5 is a lot about recognizing properties and solving. And with that, on your homework assignments, you're going to see a couple of the older things from Chapter 5 popping up to keep the memory sharp on those things or to help you get clarification on those things before we go into the Chapter 5 test. Because some of you did beautifully on the Chapter 5 quiz, some of you did not. And so we need to get clarification on those things. But the second half of Chapter 5 is focusing in on the proofs. The proofs that are in Chapter 5 all look very, very similar to one another. The focus on the proofs in Chapter 5 is proving that triangles are congruent. Now, earlier in this chapter, we talked about congruent polygons and how for a polygon to be congruent, all of its sides are congruent and all of its angles are congruent. And we can do a proof that has all of those things in it. It becomes a really long proof. But with triangles, there's some shortcuts. There's ways that you can prove that triangles are congruent in a shorter manner. And they deal with some more postulates and theorems that we're going to come across, like the side angle side congruence postulate. In a proof, we would shorten this SAS. The side angle side congruence postulate states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of a different triangle, then the triangles are congruent. Okay, so two sides and included angle. In a picture, that would be like if AB is congruent to DE, but you also know BC is congruent to EF, and you also know an angle. It has to be two sides and an angle. Now it specifically says the included angle. That means the angle between the two sides. If I'm talking about sides AB and BC, the angle between them is angle B. Which angle is the included angle of the other triangle? Those two sides, that angle was between. These two sides, what angle's between? E. If you know all three of these things, and you have to have all three of these, and they have to say congruent, not equal, you have all three of these things congruent, then you can say the triangles themselves are congruent. Triangle ABC is congruent to triangle. Now, remember when you write a congruency statement, you have to match up parts. A is here. Do you notice that A is an angle that doesn't have a marking on it? Yeah. Okay? But do you also notice that it is on the end of the single marked side? So in this picture, my unmarks are D and F. Which one's on the end of the single marked side? D. So I have to go with D. I went from A to B. B was the single marked angle, which on this one we said was E, and then C went with F. Triangle ABC is congruent to triangle DEF because of the fact that we know those two sides pairings are congruent and the angle between. So we're going to write proofs with this. Now, with our proofs, we can continue to follow our 5 things if we really want, but triangle proofs tend to actually, for most people, become easier than having to go through the 5 things. Because of the fact that in the shapes, you're looking for things being congruent. And it's always congruent. And that can help some people out. If you want to go through your 5 things, you definitely can. Now the proofs start off the same way. You got your statements, you got your reasons, you write your given. Make sure you get all of your givens into your proof. How many givens do I have here? 2 different statements are givens. B is the midpoint of AD, which sometimes I shorten down. I get a little lazy. B is midpoint AD. I keep the important words. And then angle ABC and angle DBC are right angles. My goal is to prove that I have a pair of congruent triangles. If I'm trying to prove congruent triangles, so far I only have one postulate that works in that direction. It requires me showing a bunch of other things are congruent. So, I go through my proof. I can continue to go back to my 5 things. What's the first thing you look for in a proof? Words. If you've forgotten it, it should be written on the top of your orange postulate sheet. Do you see any words showing up in our proof? I see 2 words. I see midpoint and right angle. I'm going to deal with them one at a time. I'm going to start with midpoint because it was first. Which sheet does midpoint show up on? Orange. Midpoint's right here. Definition of midpoint. Okay. Def, midpoint. M is the midpoint of AB if AB is congruent to MB. That's what it gives me there. So, I use my picture to help me out with the midpoint problem. It says B is the midpoint of AD. And according to the definition, I should have 2 congruent segments. If B is the middle of the segment AD, do you see the 2 congruent segments that are formed? By putting B in the middle of it. Creates 2 segments here and here. AB is congruent to BD, according to the definition of midpoint. Now, one of the things that's a bit of a shift in these problems is I want congruent symbols. So congruent symbols make me happy. Another thing that's a bit of a shift is I really want to make sure that as I come across congruent symbols, I mark them on the picture because that's going to help me see if I have this situation going on with 2 sides and the angle between. And it's also going to help me that as we move through 5.3, 5.5, and 5.6 over the next couple days, I'm going to give you more postulates and theorems that talk about congruent triangles. And so matching up where the tick marks and the congruent angle marks are on the picture is going to help. So, since I said they were congruent in the proof, I mark them congruent in the picture. I do not put a congruent symbol in the picture until I have it in the proof. Okay, that's congruent. If I don't know what to do next, I go back to my 5 things. Do I have words I haven't taken care of? Yeah. Right angles. Where does right angles show up on our 3 postulate sheets? And the answer is in 2 different places. It's not on the yellow one. Right angle shows up in the orange one as the definition of right angle. It also shows up on the orange one, or on the green one, in the right angle congruence theory. Which one I should use depends upon the situation. This one, do you notice there's only a single angle here? When it says this angle is a right angle. Okay? This one has two angles that it says are right angles. Does our proof have a single angle being a right angle or two of them? It has two of them. Therefore, we're going to use this one. Now, we haven't actually talked about this one yet. So we're going to add it to our postulate sheet. If you don't have your green postulate sheet out, you should grab it because we're going to write on it. The right angle congruence theorem. RT for right, angle symbol for angle, congruent symbol for congruent, theorem is THM, says that if you have two angles that it says are right angles, then they are congruent. So in this proof, I'm told that angle ABC and angle DBC are right angles. I see the words right angles, so I'm thinking I'm going to use this and say therefore congruent. Angle ABC is congruent to angle DBC. Once I have a congruent symbol written inside the proof, I go and I mark it on the picture. I know it has right angle symbols here already for angle ABC and angle DBC. I don't care. I'm going to mark over them with congruent symbols. Now, in order to prove triangles are congruent, all the shortened versions, which we only know SAS right now, all the shortcuts, and that's what these are, this here postulate's technically a shortcut to the definition. It requires 3 congruent symbols showing up in my proof. At minimum. There could be more sometimes, but at minimum it wants 3. How many do you see so far? 2, right? So we're moving in the right direction. We don't have it yet. If you don't know what to do in a proof, you go back to your 5 things. First thing is words. Do we have any words we haven't taken care of already? No. Second thing is symbols. Do you see any symbols? Yes. Now, when we talked about symbols, we talked about congruents, parallels, and perpendiculars. Congruent symbols, we like to keep congruent symbols in this chapter. We used to use definition of congruent and change them to equal signs. That works beautifully in situations where there's going to be equal signs in my proof. Do you notice that that's a congruent symbol that I'm going towards? If I have congruent and I'm going for congruent, I keep congruent. I'm not going to change it. Those are the only symbols I have. I don't have them, so I'm going to move on. The next option is substitution intransitive property. Requires the same thing showing up twice, either with equal signs or congruent symbols. Okay, within my equal signs and congruent symbols, I have A, B, B, D, A, B, C, and B, or DBC, and none of them are the same, so I move on. The fourth thing is algebra. If I have congruent symbols, I'm not doing algebra. The fifth thing to look at is a picture. Now, we've been taught to look for these 4 things in pictures, but today I'm going to add one thing. There's one more thing that you look for in a picture. And that is, if the 2 triangles that you are working with share a side or share an angle. According to my proof, I am trying to prove that this triangle is congruent to this triangle. And you don't have to highlight, I'm just highlighting for the sake of this one problem. Most of the time I don't. Do you notice either of those triangles sharing a side or sharing an angle? Do you notice they kind of overlap that middle line? It's the exact same. This side of the orange triangle is BC. This side of the orange or the blue triangle is also BC. When you have the two triangles share something, you can say that that something, in this case it's the segment BC, is congruent to itself. In the picture, I'm going to mark it with tick marks to say it's congruent to itself. I'm going to use a double tick mark this time because I already used the singles on the bottom. The property that talks about something being equal or congruent to itself is one we initially learned back in chapter 2 and we're revisiting in chapter 5. And it's the reflexive property. By the reflexive property, if a side is shared between the two triangles, you can say it's congruent to itself. I now notice that I have 3 congruent symbols within my proof. Once you notice you have 3 congruent symbols in your proof, you start looking at a single triangle in your picture and see if it matches up with a single triangle here. This picture requires 2 sides and the angle between, having congruent marks. This triangle doesn't have 2 sides and the angle between with congruent marks. 2 sides, that is the angle between. Double check the other triangle has the same thing. 2 sides and the angle between them. Yep. Once that is met, once it matches this, I can use this theorem. And that theorem that postulate states that triangles are congruent. Triangle ABC is congruent to triangle DBC by SAS. The reason that a lot of people feel that the chapter 5 proofs tend to be easier is a couple of things. First off, the proofs are shorter. These proofs tend to be shorter. Most proofs are 5 steps long. Some are 4 steps long. Occasionally they get 6 steps long, but they don't get longer than that. How often in the previous chapters did we have proofs that were 9 steps long? It wasn't uncommon. Secondly, any sort of proof where you're trying to prove triangles are congruent, the other thing that you know is that within your proof you're looking for 3 congruent symbols, hopefully. And so your goal is to just get a bunch of things that are congruent. And that narrows down a lot of things that you're going to use within your proofs. Could I use these things that don't have congruent symbols in these proofs? Technically. Am I typically going to use them? No. So they tend to be shorter and they tend to be more similar, which makes it easier to get used to doing them. Okay, we got statements, we got reasons. We got our given. BC is congruent to DA. BC is whatever that symbol is to AD. Yes, I know what that symbol means. So, first thing I actually notice in my proof is I have a congruent symbol. Once I have a congruent symbol here, I make sure to mark it on the picture. BC, tick mark. DA, tick mark. Then I go through my 5 things. Cody? What's the first of the 5 things that we look for in a proof again? Are there any words in this proof? No, so we move on. Aaliyah, what's the second thing we look for in proofs? Are there any symbols? What symbols do you see? Congruent and parallel. Congruent symbols we keep. Congruent symbols no longer count as something that we're going to deal with in these proofs. But there is a parallel symbol. Which postulate sheet has parallels on it? Not orange. Not green. Yellow. Yellow's got parallels. It's got an entire section that talks about given parallel lines and a diagram. It's our corresponding alternate interior, alternate exterior, and consecutive interior angles. So, we're going to look for some sort of an angle pair. When you're looking for some sort of an angle pair, generally you want to kind of simplify down the picture to make it easier to look at. Now, you don't want to do a whole lot to the picture in simplifying. I actually use a highlighter. If you need a highlighter, grab a highlighter. I will tell you a highlighter will be hugely helpful at this point. Find the lines that are parallel. BC. Make them longer than what they were with the highlighter. And AB. Because when you have parallels, you need parallel lines and you need a transversal. So I emphasize what my parallel lines and my transversal are with my highlighter so that I can start comparing to this picture. Now, there are 3 different lines that go through both triangles. Which line I want to be my transversal is the line that connects angles in both triangles. If I were to draw down, now I'm going to write on the active board. If I draw it on the active board, you don't draw it on your sheet. I'm just talking you through it. If I were to choose this line and I were to talk about the angles made with the parallels and the transversal, I get this angle, which is in one of the triangles, and I get this angle, which is in 2 of the triangles at once, which is not a good thing. I want a single angle showing up in each triangle. So that means that transversal is a bad one. I get the same problem here. This one is in only 1 triangle, but this one's in 2. And then the other angles aren't in the triangles at all, just to be clear. So that's no good. If I go this one on the other hand, the orange and the red that I have right now make this angle that's inside that triangle, and this angle inside this triangle. Now be careful, some people try to draw this angle, but that's not made with the red and the orange, and you have to go all the way to the orange, and then part of it's inside the triangle, part of it's not. That's no good. So, the third one that's going to be helpful is this line. Because that line, that transversal, makes an angle in this triangle and an angle in this triangle. It makes this angle and this angle. I need to know what kind of angle pairing those are. If this is my transversal, those are my parallel lines. It's like spots in 3 and 6. 3 and 6 are what kind of angle pairing? Alternate interior angles. So, when I see parallels, I'm going to be using angle pairs from chapter 3. In this case, I'm going to use the alternate interior angle theorem. The alternate interior angle theorem says those angles are congruent. So I'm going to say that these angles are congruent in my proof. I just have to make sure I call them by the right name. This angle right here, its vertex is C, but can I call it angle C? No, because then I'm going to ask you, do you mean this angle C, or the big one? want this angle C. Aiden, what is the 3-letter name of that angle? This one. Angle BCA. Don't forget the angle symbol. Is congruent to angle. Okay, now I need this one. Jasmine. What's the 3-letter name of this angle? You got it. CAD. I have a congruent symbol here. I mark congruent in my proof. It's angle, or in my picture. It's angles, so I do angle marks. Okay. How many congruent symbols am I going for looking in the proof again? How many do I want? 3. The postulates and theorems has 3 to tell me triangles are congruent. I only have 2 currently. I need 1 more congruence at least. So, I go to my 5 things. Words, we already established it, were not there. Symbols, we had a parallel, we took care of it. This is how we got that one. Transitive and substitution. Amongst my congruent symbols, none of the stuff is the same. Parallel and congruent don't work together for transitive or substitution. I can't do algebra, so I'm looking at the picture. What was that, Jackson? Nope, we're looking at the picture. So, with the pictures, I don't want linear pairs if I can help it. If I see linear pairs, I might work with them, but I don't want them because that's supplementary. Do I see any vertical angles in this picture? Do you see any lines crossing like that? No, there's no vertical angles. I'm not adding up segments. I'm not adding up angles. The new one that I told you is do the pictures, do the triangles share a side. Do my 2 triangles share a side in this picture? Yeah. What's the name of said side? Jackson?
CD.
Sorry, what was that?
CD.
They don't share CD.
Oh, AC.
AC. They share AC because this triangle and this triangle, they overlap at AC. So AC is congruent to AC. Jada, what property said something's congruent to itself?
Reflex.
It's the reflexive property, reflex. I put a congruent symbol in here. I make sure to do the congruent symbol here. I'm going to do the double tick mark. Since it's the same line, I only have to do a single double tick mark. And then I double check. Since I have 3 congruency symbols, and right now we only know this theorem, is it 2 sides in the angle between? 2 sides on that triangle is the angle between them, the congruent angle. Yes. 2 sides, is it the angle between? Yes. Once you have that, you can say the triangles are congruent. And it wants to say triangle ABC is congruent to triangle CDA. And our reasoning, since it was 2 sides in the angle between, is side angle side, SAS. That proof is 4 steps. Like I said, these ones are shorter. Okay. So, we've got 2 more. Y'all know how to start the proofs. Okay, PQ bisects angle SPT and PS is congruent to PT. First thing I notice is there is a congruent symbol. I always look for that first because I want to make sure I get them in my proof. PS, that's a side. PS, there. PT, also a side. PT, there. I mark them. I always mark them in the picture. Diego, what do you notice next? Go to 5 things if need be.
Symbols.
What goes before symbols?
Word.
Words. Do you see words?
Bisects.
Bisects. Which sheet has bisect? If you don't know, just start looking.
Orange.
Orange has bisect. It's got 2 different bisects. Segment bisect, angle bisect. PQ bisects angle SPT. The second thing is what got bisected, so it's angle bisect. Oops, helps if I point to the right thing. Def, angle, bisect. When an angle gets bisected, we get 2 congruent angles. To know exactly what angles, use your picture to your advantage. Angle SPT was bisected by PQ. If I kind of darken them in and highlight them, the original angle all of a sudden has 2 angles right next to one another. You see these 2 right next to one another? Those are the congruent ones. The top one is called SPQ. The bottom one is called TPQ. Oops, don't forget the angle symbol. When I mark a congruent symbol in the proof, I mark it on the picture. And I go back through my 5 things. Do I have words still? No, I see people shaking their heads. Good. I have symbols, but they're congruent symbols. Do I want to do anything with congruent symbols anymore? No, I like congruent symbols. I keep congruent symbols. I move on. Transitive or substitution? No. Algebra. When there's congruent symbols, you don't do algebra. You skip right over it. I look in my picture. In my picture, I look for things like vertical angles or linear pairs, or that they share a side or an angle. Do the triangles. I don't see the X for vertical angles. I don't see a linear pair. Do the triangles share a side? Yes. So I say it's congruent to itself. Charlie, what's the name of the side that they share? So PQ is congruent to PQ. Aria, what property is that? Reflexive property says something's congruent to itself. Reflex. Where do you think we can go next? Ooh, other than marketing on the picture. Anyone notice about the things in our proof and what we have so far? Do you notice how many congruent symbols there are?
We have enough to prove.
Hmm?
We have enough to prove.
Yes, We've got 3 congruent symbols, which means we most likely have enough to prove. It won't always be. To double check to make sure. The only option we got is 2 sides with the angle between. If I look at a single triangle, is it 2 sides and the angle between them? Yes, then I have enough to prove. Triangle SQP congruent to triangle TQP. Mariana, what property is that? The noticing the 3 congruences or the right congruences? Yes, because it was 2 sides and the angle between. As we move forward, we're going to have other options. We do have to do the last one because it's got one other thing that I need to make sure that we see before we jump into our proofs today. Technically, we've seen it before, but I want to make sure that we know that we can look for it. This is probably going to be one of the longest proofs that we get, but it's also not a long one. I look at this one, I see words. I see the word bisect first. Since both of those are segments, it's segment bisector. Keep in mind that the second one is the one that got cut into 2 parts. SV got cut into 2 congruent parts. They break at U, so VU is congruent to US. Definition of segment bisector. And I'm doing that part quickly because of the fact that we've seen a lot of times popping up, and we already did a bisect one. This one was just a segment one. The other word was midpoint. Midpoint, if U is the middle point of WR, it says WR gets broken into 2 congruent parts as well. Tells us WU is congruent to UR. The 4th step is the one that I really wanted to focus in on, that I wanted to talk about a little bit. So, I've got this much in my proof. If I look through my 5 things, there's no words. The symbols are only congruent symbols. I like them. There's nothing for transitive or substitution. There's no algebra that can be done with congruent signs. I'm looking at my picture. Do my 2 triangles share a side? Because that's what we've seen so far from the pictures. They do not share a side. They do not share an angle. They share a vertex. They share a single point, but sharing a single point is not helpful. Has to be full sides or full angles, because we can't say a point is congruent to a point. So, the fact that they share a vertex tells me that I'm not going to use reflexive property. It's telling me I'm looking for something else. Do you see the X forming? Do you notice that the triangles are across from one another on the X? I have vertical angles. And vertical angles are congruent by the vertical angle theorem. So, don't be shocked if you see vertical angles. Remember, when you're doing vertical angles, you also need the 3-letter name. VUW and SUR. Once I have that, I have 3 congruent symbols, and the picture has 2 sides and the angle between. So it is side angle side that tells me my triangles are congruent. But I just wanted to emphasize that you can do vertical angles as well. Okay,